So in this video, we're first going to look at distance time graphs and displacement time graphs. We're then going to look at how we calculate velocity using the tangents to the curve of a distance time graph, which is a higher level skill. So now let's look at how we can display the motion of an object graphically. So first of all, a distance time graph. What's the significance of the gradient is one thing to think about. Well, the gradient is y divided by x, that's distance divided by time. And of course, distance divided by time is speed. So the first line here will be travelling at a constant speed, and of course that constant speed is the change in distance over the time taken, and the change in distance is 20 meters. The time taken is 20 seconds, and so that gives us a speed of 1 meter per second. Here you can see you're not travelling at all, you're not moving, so you're stationary. And here you're travelling at a lower constant speed. So here is a lower constant speed, and if you had to work it out, of course, velocity is distance over time, and the distance travelled is from 20 to 40, so that's 20 meters, and the time taken is from 40 to 100, which is 60 seconds, and that gives you a third, or 0.33 meters per second. Now you notice here I've now put a blue line on the graph, and that blue line shows you what's called the average speed, because that is the constant speed that you would travel at to get to the same point in the same time. So if you want to work out an average speed on a graph, just draw a straight line from where you start to where you end, and so the average speed is just your total distance divided by your total time, which in this case is going to be 40 meters divided by 100, which is 0.4 meters per second. Right, on to the next one. So what I want to do is to pause the video and have a look yourself and describe the motion of each part of this and calculate the velocities. Off you go. So the first section, of course, is a straight line. It's a constant speed, and the speed is distance divided by time, which is 10 divided by 20, 0.5 meters per second. The second part is, of course, stationary. So the next part is again a constant speed, as the gradient is the same, but it's a speed of distance divided by time, 30 divided by 20, which is 1.5 meters per second. Finally, again, it's also a constant speed, but coming back in the opposite direction. And of course, velocity is distance divided by time, 40 divided by 40 makes 1 meters per second. So you also have to be able to interpret a curved graph rather than a straight line. And so you'll notice that as you go along the graph, the gradient is getting steeper. And remember, the gradient of a distance, or especially displacement time graph, is velocity. And therefore the velocity is increasing, so the object is accelerating. And of course, if you see one this way round, then you can see the slope, the gradient of the curve, is getting less with time. So the velocity, which is the gradient, is getting less, which means it's decelerating or slowing down. Now, at the very high level, you have to also be able to calculate the velocity at a certain point. So in this question, we're asked to calculate the velocity at a point at 60 seconds. Now that's the tangent to the curve, and the best way to draw a tangent to a curve, I can't do it on my tablet, so I've had to put this on in advance, is first of all to draw a dotted line at right angles to that curve at that point. It is much easier to do it this way round. So first we'll draw a line at right angles, and then of course the tangent will be at right angles to that. So get your plastic ruler, see-through ruler, and of course your see-through ruler has lines all the way along it, so line one of those lines up here, and you will find that the ruler length is exactly at right angles. And of course what we then have to do is we have to find the gradient, because that is the velocity. And my scale's not very good here, but you get the idea that if you had graph paper, then suppose that was 90 seconds and this was 38, then we could say the velocity is equal to the change in distance over the time. And so the velocity is going to be, well, the change in distance is 40 and the time taken will be 90 minus 38, and that is 52 seconds. So that's 52. So that gives us 0.77 meters per second. So I want you now, if you've got the sheet, to have a go at this one and pause the video. If you haven't, just again watch my explanation. So we've got to calculate the velocity at 5 seconds. The first thing I'm doing is I'm drawing a right angle on that line there. And then of course I'm going to draw a right angle to that, which is a tangent to the curve at that point. And then I've got to measure the gradient. So my axis only goes up to here. So if I measure that there, that's going to be each square is worth, can you see there are 10 squares in 5, so each square is worth 0.5, so that is 20.5, and that 0 is worth working this out first, and then that is 6 going down, and this is 3.2. So 6 minus 3.2 is going to be 2.8 seconds. So make sure that you've worked that out. That's the change in y and the change in x, so that will be the gradient. So we can say the velocity is the change in distance over the time taken. The change in distance was 20.5. The time taken was 2.8 seconds, and that gives me 7.3 meters per second.